So consider this problem statement. So it states that in the quadratic equation, that is p of x equal to 0. So from this statement it is clear that this p of x function represents a quadratic function. So when quadratic function is equated to 0, so that turns out to be a quadratic equation. So the coefficients are real, right? And this quadratic equation has purely imaginary roots. So if that is the case, so in that case it is asking the equation that is p of x, that is the composition of function, that is equal to 0. So for this equation, these are the options that are given. It will have only purely imaginary roots, option A. Next option says that will it have all the real roots? The next one says two real roots and two purely imaginary roots. And option D, that says that neither real nor purely imaginary roots. So now let us proceed towards the solution. So if you observe the problem statement, since it is given that p of x is equal to 0, this is given to us, right? It has purely imaginary roots. So in that case also the coefficients, the coefficient of x must be equal to 0, must be equal to 0. So let us make an assumption, let us say that p of x is representing, that is ax square plus b, and definitely a cannot be 0 here because it is quadratic function, and then a and b belongs to the set of real numbers. So definitely a will belong to the set of all the real numbers. This will represent set of all the, let me just write it clearly, set of all the real numbers but not 0. So a can take all the real number except 0, and b will again belong to the set of real numbers. So this is the situation now here. Now since the roots, are purely imaginary, so in that case we can say, we can state that ax square plus b equal to 0, and this further implies, this further clearly implies that x square is equal to, that is minus b over a, and this is definitely a negative quantity, right? So from this one we can state that, here this coefficient of x square, which is a, and coefficient of x to the power 0, that is b, with b if no variable is there, definitely x to the power 0 is there, where x is definitely non-zero. So a and b are of the same sign. So this is the idea. Now if I consider, that is p of x, that is, on resolving this I can write here this part as ax square. So I can just go this way, that instead of x I'll write p of x over here, and here plus b, and again further this p of x will be replaced with this a x square plus, this will be plus b, and this will be squared over here, right? So this part should have been squared like this because it is ax square, right? Now after that here plus b. So this is my p of x. Now for the real value of x, that is for the real value of x, I can say that this particular quantity, this selection has to be greater than, this is definitely greater than or equal to 0, right? Now so from this we can say, so this quantity, that is a times this particular expression, this has the same sign, as a. So whatever is the sign of this variable a, that will be the overall sign of this given expression. Now since, if I comment about b, since b also has the same sign, as a, which we have established here, right? So since b is having same sign as a, so from this we can say that this expression, that is a x square, a times ax square plus b, and this is whole squared, so this is definitely not equal to 0, right? So from this we can say, thus this p of x, which is equal to 0, this equation has no real roots. So this part is established here. Now if I talk about for purely imaginary roots, so in that case I will substitute x as iota times y. where definitely this y belongs to the set of real numbers, right? And also this iota is nothing but the square root of -1. Now if I solve for this part, that is p of iota times y, so this can be written as a, and then this part b minus ay square, and this is squared. I have resolved it basically, and then plus b. This cannot be equal to 0. This will not be equal to 0 again, because here both terms have the same sign, correct? So hence we can say that p of x, which is equal to 0, this given equation has neither real roots nor purely imaginary roots, and hence from this we can clearly observe that option D is the best match here. So therefore answer is in option D, and hence we have solved this part.